Okay, so today's work isn't actually dissimilar to what we were doing last week. We're just going to add that layer of friction in as well. So a couple of examples. First one, a particle of mass 5 kilograms is pulled along a rough horizontal surface by a force of magnitude 20 newtons. The coefficient of friction between the particle and the floor is 0.2. So please do draw a force diagram. Just get into the habit of doing that. You can, if you want to, model your particles as so. Sometimes that's easier just so you can see what's happening with the forces. And we're being pulled along with a force of magnitude 20 newtons. You can go that way or that way. I tend to go to the right, but... And then the frictional force, it's a rough surface, so there will be friction, and the frictional force will oppose motion. Weight acts down, so that's going to be 5g, and the reaction force is perpendicular to the surface. And we want to find friction. So we're using F max equals mu r. So if the object is in motion, the friction will be at its maximum. It also will be if it's on the point of sliding or in limiting equilibrium, then friction will be at its maximum just before motion. So to find F, we need to resolve forces to find R. So resolving vertically. This one's nice and easy. Forces are in equilibrium, perpendicular to the plane. R is equal to 5g. G is 9.8, and so R is equal to 49 newtons. And then F equals mu R. You can write F max if you want, or just leave it as F equals mu R. There's a lot of F's and there's a lot of R's in A-level mechanics. So if you want a way of distinguishing between the two, writing in F max doesn't hurt. And so the friction is equal to the coefficient of friction, which is 0.2 times 49, which gives you 9.8 newtons. And the next thing to do is find the acceleration. And so to find the acceleration, we can resolve in the direction of motion, which will be horizontal. And we're using F equals ma. So you can use that sum notation just to remind yourself that you're finding a resultant force. And so resolving parallel to the surface, 20 minus F, so 20 minus 9.8. So we're taking, it's moving this way, so I'm taking that direction as my positive. And that's equal to ma. And then from there, you can just subtract, divide, and A comes out as being 2.0 meters per second squared to 2 sig fig, because we've used G to 2 sig fig. So that's sort of as easy as a friction question will get. I'll put in a force at an angle quickly as well. So we're going to do a similar question. I don't really want to rewrite it all, but have that pulling force at an angle to the surface. So, rough surface, particle. This one's going to have mass 8 kilograms. And the coefficient of friction is going to be 0.4. And this time, this force is going to be at an angle of 25 degrees to the horizontal. I think you should be able to read that. And magnitude 30 newtons. And so drawing in the forces, motion's in this direction, so that's going to be positive direction. Weight acting down. Normal contact force, normal reaction force is perpendicular to the surface. And then we've got friction, opposing motion. And so running through the same thing, so the first thing I want to do is find the frictional force. We need to use F equals mu r, so the first thing to do is to resolve vertically to find R. But the difference now is that I also have a vertical component of this force to consider. We're in equilibrium vertically, so perpendicular to the surface, there's no motion. And so force is acting upwards, so R plus 30 sine of 25. So that gives you the opposite, which is your vertical component, opposite to the angle. And that is going to equal 8g acting down. And so R is equal to 8g minus 30 sine 25. You could put that into your calculator at this point. So I can do 8 times 9.8 minus 30 sine 25. So that's 65.721. Again, you just need to be on the lookout for these rounding errors. So I would personally, I know I'm going to use that again, so I would just do store x and then it's there for when I want it. So from there, to find the friction, F is equal to mu r. And so F is equal to coefficient of friction times 65.721. So 0.4 times x. So that's 26 newtons. So I'm going to ignore that. I'll try to. The next thing I want to do, let's answer it and hang up. The next thing I want to do is find the acceleration. So I need to find the resultant force. So I'm going to have to use this. So I'm going to now store that one to x. So store x. And then, so for B, to find the acceleration, we can resolve horizontally. And F equals ma. So I've got 30 cos 25 acting in this direction. I'm hoping you're pretty confident with your forces from last week. If not, minus the friction. I have put some consolidation work from your books on Moodle under the directed study tab, and that's equal to 8 times A. It's the acceleration that we want, isn't it? So now on my calculator, I can do 30 cos 25 minus 26. No, not minus 26, that's the thing I didn't want to do. Minus x, and then divide by 8. So just be careful you don't get a rounding error by popping that into there in an unrounded form. And A comes out as being 0.11 meters per second squared. The only other thing I'd say you could do is you could just write F to quite a lot of decimal places and then round it and then use your unrounded answer. But if you're happy, you know, sort of manipulating that with your calculator, do, but just keep an eye out for these rounding errors. Right, I'll let you do a few of those as a sort of starter.